joint, and inverse variation. Remember, if it's a direct variation, it's going to be a variable multiplied by your constant. If it's joint variation, you're going to have several variables multiplied by your constant. And if it's your inverse variation, we're going to be doing your constant divided by your variable. And in problem 16 and 20 that I picked, it says state whether each equation represents a direct, joint, or inverse variation, then name the constant of variation. When we're looking at problem 16, all your variables are on one side. You should have a variable on each side if you're going to solve it. So going in here, let's take and divide by one of the variables. So dividing by W, I'm going to have V equals negative 18 over W, so it's a division, so that means it's going to be an inverse variation, and it means that my constant of variation is going to be negative 18. Looking at problem number 20, you can see we have two variables on the right-hand side, so that makes it a joint variation, and my constant of variation will then be that K value, which is a 1/3. Couple story problems when you're setting it up. The idea is to set up the equation. So when you're looking at problem 26, if y varies directly as x, and y equals 15 when x equals 3, we have to find y when x is 12. It says if y varies directly as x, that means y equals k times x. K is my constant of variation. I substitute in what I'm given. I'm given y is 15, x is 3. So when I solve it, I find out that my k value is a 5. So now my equation is y equals 5x. I can find the y value by taking 5 times my x value of 12. So y will equal 60 in this particular problem. Continuing the same idea, I tried to do one of each. Now we have y varies jointly as x and z. That varies jointly means we're going to do a multiplication. So y equals k times x z. Y is going to be 80. When we have x is equal to 5 and z is equal to 8. So solving that, we can find out that we have k is equal to 2. Once I know the k, I can plug it back in and find out my y on my other equations. So y equals a 2 xz. X is equal to a 16. Z is equal to a 2. So when I go in and multiply, I get y equal to 64. And then continuing on with it varies inversely, we have if y varies inversely as x, and y is equal to 2 when x is 25, this time we're going to find x when y is equal to 40. It varies inversely means that we are going to go in and do a division. So y equals my constant divided by my variable, which is x. My y value is a 2. The constant is what we're needing to find. My x is a 25. So it turns out that k is equal to 50 when I cross multiply and solve it. Plugging my k back into my equation, I have y equals 50 over x. Substituting in to find the x value, I'm going to put a 40 in for y. And I get 50 over x. Cross multiply, I get a 40x is equal to 50. Solving for x, I get a 50/40ths, which if you simplify it up, becomes a 5/4 for my answer. Moving on to a story problem 1, I picked problems 41 through 43. It says use the following information in order to sustain itself in its cold habitat. A Siberian tiger requires 20 pounds of meat per day. We have to write an equation to represent the amount of meat needed to sustain S tigers for D days. So the meat we need, meat equals the 20 pounds for however many tigers for however many days. So we have M equals 20 SD. Question 42 says, is our equation a direct, joint, or inverse? Because I have multiple variables on the right-hand side being multiplied, it's going to make it a joint variation. And then question number 43 says, how much meat do the 3 Siberian tigers need for the month of January? I just plug in my information. We have 3 tigers, that's my S. 31 days are in January, so that's my D. Go through and multiply it out. You come up with 1,860. Remember, it's a story problem, so you should label it. So we have 1,860 pounds.